Congress.
All right, guys. It's 6:35, so let's get started. All right. So we finished the word problems, right? So we did some examples of that. Now we're going to start looking at tensor operations. Okay. Guys, you have a seat. All right, guys, let's get started. All right. All right. So let's start with the second half of today. Okay. So in this section, we're going to start the coding process. Okay. Which is what we'll be doing most of the semester. Remember that what we're going to be building basically neural networks, that are getting more and more complicated as we move further along. So I like to start with tensor operations. Okay. To me, this is like the secret sauce. Okay. If you want to think of it that way. So this is really where you're going to get stuck in deep learning. You'll see a CNN or whatever, and you'll get some of those principles really quickly and easily. But when it's time for you to modify it or to do operations, you're going to get stuck if you don't have command of this, okay? Which are, as I said, tensor operations. So I don't have time today to go over the 109 problems that I have on the GitHub. What I'll do as many as I can today. My recommendation is you should do them on your own. Okay, I'll point out in a second the link. And as we go through the semester, I will touch on some of them that I think are important, like an operation called broadcast, right, which is really important in deep learning. And we'll go over what that is. It's actually a little bit abstract and confusing, but you really, how can I say this in a way that you understand? So someone pays you a certain amount of money to build a CNN, and you can charge a little bit extra because you know how to do these tensor operations in there. All right. That's the thing. That's a skill that not everyone will have. You see what I'm saying? So that's the thing that you need to understand how to do efficiently. Also, when you start reading algorithms like transformers, etc., if you don't understand these operations individually and separately, you're not going to understand the whole thing. All right. Because a lot of it inside will be performing a lot of broadcasting operations or different kinds of projections and things like that that just won't make sense to you initially. Okay, so in the problems that I have, I've tried to provide examples of many things, like, for instance, positional encoding. What is that, right? So that's something that you need in transformers, but really we should break it down into a smaller operation to get a sense of how that works. You see what I'm saying? So these are all, in a sense, these 109 problems are some of the building blocks that you will need later on in the more advanced algorithms. Got it? All right, that's all I can give you right now. So what I suggest is, as I said, click on these and in your spare time, go through them. Even just like manually go through them, practice them many times, and you'll see me touch on, at some point in the semester, I'll go to problem 47, and we'll spend a little bit of time on that one. Got it? Make sense? All right. Anyway, I have to start at the beginning, so some of you may know maybe like numpy ninjas already or whatever it is. So, but I'll start at the beginning with just giving some basics of how to create these with numpy and PyTorch. All right, and that's why I call it tensor operations, because they're not just numpy. But the thing is, nowadays it's really nice because it's very easy from PyTorch to switch to numpy, do some operations in numpy, send it back to PyTorch and so on. Okay, so you will be using both of these as you develop your tools. This is not about pandas or anything like that. It's mainly focused on NumPy and PyTorch tensor operation. Okay, all right, so I'll start with these first 15 that I have in here, just to kind of, show the point of it. But we are creating matrices and vectors, and then later on, we're going to start to transform them in some way by performing matrix multiplications, and I'll describe what that is, as we go through the semester, okay? And then hopefully at some point when we get to the transformer, I'll say, remember that positional encoding problem? That's this thing here, okay? And so hopefully that'll make that very complex algorithm be a little bit simpler, okay? All right, so let's start. So I have it on my laptop here. I'm going to show you the basic pipeline, right, that you should follow, which is I'm going to use Anaconda for most of the operations. So I'm using Windows here, but you can do this on Mac or Linux. I'm sure, I showed you the link last week, right, of what you needed to download. I said Anaconda, you've installed it on your computer, I assume. And so now I usually on Windows, I will use the Anaconda prompt. It's a terminal, okay? So then I'll open this. It's Windows, I'll use dir. I'll cd into desktop. dir. And then in here, I'll create a folder for the semester. Question? Yeah. So I'll do it on the Windows approach here. So I'm just going to go over here and I'm going to create, okay, a folder. And I'm just going to call it 2024. What is this, fall? And this course is 520. Right, ITS 520, 2024 fall. All right, so I'll just put all my files in here. Go back to the prompt. Okay, and I should be sharing this window, I think. So you guys will see this, okay? So in Windows, I think it's CLS, yeah. All right, and I've already installed Anaconda. So if you guys have installed Anaconda and you open this, this should say base right now if you're opening this for the first time. Okay, everyone with me? So you would go, again, download Anaconda, double click on it or whatever, run through the installer. And then when you do what I did with, you can follow the video again, right? Go to apps, Anaconda prompt, open this, and you're good to go, okay? Questions? Pardon? Yeah, I'll use Jupyter Notebooks all semester pretty much, yeah. Okay, all right, everyone with me? So let's keep going. So I created a folder, a dir again, and the folder is ITS 520, 2024 fall. So I'm going to cd into that. 520, 2024 uppercase fall. Okay, should be there. There's nothing in here now. Okay, there we go. Now to the environment that we're going to use. So you can use the command conda environment list. I will have several environments here, but you may not have environments here. So I'll go ahead and create a new one for you guys in case you've never seen how to do this. So I need to get rid of some of these. All right, so I'm going to do conda create. So I have a set of commission. So on my GitHub, I have a repo called what is it called? Unix and Python scripting. And if you look through that, there's a file in there called conda commands.txt. Okay. So if you find that again in my repo, in my GitHub thing, I have a repo called Unix and Python scripting. Within that, I have a text file called conda commands.txt. If you look at that, it'll have several Anaconda, the most common basically commands that you can use. Obviously, you can just research this on your own, Google it, etc., and learn a lot about Anaconda, but these are some useful commands. Got it? Everyone with me? All right, so the first thing that I'm going to do is I'm going to create an environment that I'm going to use this semester, okay? You see what I'm saying? And you can just use this environment all the time. You only have to create it once on your machine, right? On your laptop or something. So how does that work? I'm going to do conda create. This only works, again, if this says base, which means you've installed everything correctly. Conda create -- name. And then I'm going to give it a name. So I'm going to use Python 3. I can use 3.8, 3.9. I'm going to use, I think it doesn't matter, but I'm going to use 3.8, let's say. And I'll give it a name like ML 520, just so I know what I'm doing. Got it, guys? Actually, I'll just do 2024. I'm confused. You can give it any name you want. But in my case, I have several environments. It might confuse it. All right. I always like to put Pi 38 or Pi 39 just so I know which version of Python I'm using. You know, Anaconda is a version controlling system. So that way some applications will use Python, you know, 3.10 or 3. You may need something with 3.7. So it just makes it easier on your computer to handle different libraries. Okay. And you can get rid of it when you don't need it and so on. Got it? Everyone with me? All right. So conda create -- name Python 3.8 ML. Okay. And then I'll provide the Python version. That's usually what I provide in the beginning. So this one will be 3.8. And then you need to have internet access. When you hit enter here, you know, it starts to install all the libraries. I like to usually just install Torch on here and then Jupyter. And then from there, I'll start the Jupyter notebook, and any other libraries I want, I just install them as I need them, okay? And so this will be so you can hit yes. And that's all you have to do to create your machine learning environment. Pretty straightforward, okay? Again, this is being recorded, so you can just replicate this later on from the video. Okay, any questions? Any questions for anyone? Okay, all right, so we built from scratch. The only part I didn't show you is downloading the Anaconda thing. That's Windows, so you should be able to do that very easily, okay? And we discussed that last week. So as you can see, it's installing some default libraries. We'll give it a minute and then install Torch. When you install Torch, it usually will install other libraries like numpy, hopefully pandas, and then I will just add Jupyter, which will be our editor for this semester. Okay, we can basically, you'll see at the, you know, towards the last 4 weeks or so of the semester, we'll code up a transformer, you know, in Jupyter Notebook. That should work, and so on. All right, so you can see here, it finished. So now I'm going to do CLS. I'm going to do pip. I like to use pip. Install Torch. So while it's doing it, I'll talk about Torch. How about that? All right, so I'll give you my whole spiel on Torch. All right, so no, I'm kidding. So, but I will say this. So some of you have heard of TensorFlow. How many of you have heard of TensorFlow? Okay. How many of you had heard of Torch? Okay. So TensorFlow is Google's solution. Torch is Facebook's solution. Facebook doesn't want to use Google products, so they invented their own thing. You see how that works, right? So I started with TensorFlow 1. I really like TensorFlow 1, actually. I was the only person probably. They changed to TensorFlow 2. It was a really big change when they made it, like a really big update. And it was so big, and everyone was saying that Torch was actually really great, that I just kind of decided, you know what, I'm going to learn Torch instead. And Torch is, I like Torch a lot. It's my favorite, actually. And a lot of people use Torch. I'm not saying anything bad about TensorFlow necessarily. It's just a preference. Right? I like Torch. You know, a lot of these algorithms are very similar from one language to the other. It's like they copy each other, honestly. And then both of them copied NumPy. So it's kind of, so everyone, you know, it's basically like that. It used to be that things were very different over the years. Now they're very similar, which is a good thing. And it's a healthy thing to have a nice competition. So I'm actually very, Facebook is like this thing where they used to steal all your data and didn't respect your privacy, but they really did a good job with AI because they've created a second option for AI. So you can appreciate that. All right, anyway, so that's it. So what is Torch? It's, just really quickly, it's just a library. All right, we're going to use Python, which you should have as a requirement for this course, some knowledge of Python. And basically, we import the library of Torch. Torch is a set of algorithms optimized in C++, right? But you can bring them into Python to create your machine learning algorithms. In this case, neural networks and deep neural. Everyone with me? So it's just a library, very powerful library. So Keras is a simplification of TensorFlow. We will not be using Keras in this class. So the whole class is in PyTorch. Keras, there's like the from scratch code, right, that you would write in TensorFlow. And then there's like a more simplified version of that using Keras. Keras is like the easiest entry level thing to TensorFlow, but it's not for PyTorch. This is not a course for Keras, sorry. Right? You can look for another course where they'll teach you Keras. So that's basically the idea. Okay? Any other questions? Okay. All right. So it's still installing, but yeah, that's basically the library. It's called PyTorch. The import is just Torch. And it's installing, several things. So it might take a while. All right, finish. There we go. And then the other thing I like to install here is Jupyter, like somebody said, that will be our editor. So you can just do pip install Jupyter. And I'm sure you guys are familiar with Jupyter notebooks. So, and then after that, there will be many, many libraries that we have to install. Okay. I made a request today for the Scholar Cloud thing that they have available. Hopefully we'll get it. And if we do, you'll use a very similar approach. You just have to know how to select the GPUs later on, okay? But I don't have it yet. Once I have it, I'll let you know. But I did make the request. All right, so I believe everything, you should always check the output here, make sure there are no errors, anything like that. If it looks like this, hopefully everything went okay. I just installed Jupyter, so I'm gonna do CLS. All right, now I'm gonna do Conda. Oh, I made a mistake here. I'm sorry. I apologize. I was distracted. I should have done all of that in the environment, and I didn't select the environment. So sorry about that. Conda environment list. I did it in the base environment, which is not what I was going for. So what I should have done is when I created Pi38 ML2024, I should have done Pi38. So Conda activate Pi38 ML 2024. Like that. So yeah. So what that does is it takes you out from that base into the new environment that I created. Oh, did I misspell it? Sorry. Okay, there we go. So I'll do this. Okay. Now I'm going to have to repeat what I did before, because what I did is I installed all those libraries, but in the base environment. You guys see that? And that's not actually what I wanted. So now I'm going to install Jupyter. So hopefully it'll be fast. And then I'll install Torch and then Jupyter, and then we'll get going. Any questions while it's doing this? Got it? All right. Yes, let's give it a minute. There may be some, so while it's doing this, there may be some classes sometime in like the end of September where we have to do them on Zoom. So I won't be able to come. So I'll send you an email and we'll just schedule them so that you guys can use the Zoom environment. Okay, but it won't be the whole semester, just it'll be a couple of weeks, like possibly. So I'll let you know when that is, but it should be towards the end of September. Again, I won't do this every time, but I have to do this one time. The machine. Just Torch and Jupyter for now. All right, so it finished, and then we are in the environment, and I have to install the Jupyter also. Shouldn't take that long. Pip install Jupyter. Okay. All right, finally, right? So it finished. All right, so I'm gonna do CLS here. So we are in the environment Py38 ML 2024. I've installed hopefully just what I need. So now I'm gonna start the Jupyter notebook, and this is where we're gonna do the editing of our code most of the time. So I should do Jupyter notebook. Also, another thing I'm gonna look at is where I am. So dir. Okay, so I am in that folder, ITS 520, 2024. Pay attention where you're saving your files, right? Because we're gonna start creating files and they're gonna be created in this folder. So now, Jupyter Notebook. Just like that, right? So Jupyter Notebook, hit enter. And if everything installed correctly, it should open the web browser with our Jupyter Notebook. And there we are. So now if you look over here, I'm using Py38, so different versions look a little bit different. What I'm going to do is I'm going to create a new Jupyter Notebook. So just give you a really quick of how things work. This is usually where your files are going to be. If you have anything running, if you click on this tab, it's going to appear here. I usually turn it off when I'm done. You'll see me do that. And then all my files are going to appear here in the environment. I can create by doing new, and I'll do Python 3. And there it is. It creates, okay. Yeah, so it creates an untitled. I must have double clicked on this. So I'll close it. And then go to running, and you see it's running there, so you can just shut down. Okay, and then this is my file. So now I'm going to double click on it. There it is. So it opens a new page. Okay. And we can create. So basically, this is what a Jupyter Notebook looks like. If you click on plus, it just adds new cells in there where you can write your code, basically. Got it? All right. First thing you probably want to do is it by default is called untitled. Just change the name. I'm gonna do file. I'm gonna rename it, and we're doing NumPy examples. So I'll just do NumPy 1 to 15. Okay. I'm gonna rename it. All right, and there we are. So hopefully we can start doing some coding here. I'll just do a couple of things. I like to make some of these cells like informative. So I'll just say problems 1 to 15 in my NumPy. I'm gonna hit run, cell type, change the markdown, and there you go. So now I have. All right, so we're gonna start with some basic things of NumPy, right? And as I said, you're just gonna build up, look at also torch tensors. And these are the constructs that we will be using. So tensor, as I said, just means a vector or a matrix, right? The program TensorFlow literally means a flow of tensors. You can see how important tensors are, that it's in the name, right? PyTorch doesn't use that, but it's the same framework, okay? So the first thing I would usually do here is kind of look at the libraries to see that they're installed correctly. So some of the libraries that we will be using right now are numpy and torch. I'll start with numpy. So import numpy as np. So you type it up and then you hit, you kind of run it. Okay, so it's not installed. Yeah, it's not installed. So you can see that, this went black for a while, it gave me an error. So that means that it wasn't installed by default. So I'm going to go ahead and show you. Usually what I do is just something like this. Notice that's an exclamation mark and then pip install numpy. Does that make sense? And then you can just install from here. So in theory, you don't have to go back to the terminal and install all the other programs. I usually just install some of the very basic ones and just makes my life easier. Yeah, go ahead.
Are we using the on-time environment that you?
Yeah, did I not use that one? Is that not the one? I thought that's the one. Torch should be there, I think. Plus, we're in the Jupyter. I'm not.
I don't know myself.
I think I'm using that. I thought I was.
But usually when you install numpy will be installed.
I know that's a good question. I assume if I do well, one way to find out is I can restart it, but if it doesn't find torch, then I'm probably using something else. It's there, so
You can install it in the host environment.
I may have done that. That was a mistake I made. So, all right, so we'll fix it. I'll create the beauty about Anaconda, just destroy it and create a new one. All right, so but yeah, good point. So anyway, I hopefully installed numpy here, right? So as you can see, now I'm going to comment it out because I usually leave it there so that I know that that's something I did. It's now I'm gonna try it again. Okay, you can see the dot is white here, so that means it found the library, no error. Okay, I usually put all the libraries together, so I'm not wasting space. So I'm gonna get rid of this one, so just use the scissors. Okay, I'm gonna try it again. I like to save, and okay, so that means it's there. Does that make sense? Little by little, I might add matplotlib at some point. It may not be there, so we do the same. Exclamation, pip install matplotlib, and we can just continuously add our libraries as we need to. Got it? All right, so that's your environment. So that's actually a big deal, right? Getting that environment set up, getting it to work, practice using that, and then from here on out, we can code whatever, okay? All right, so now I'm gonna start, as I said, just doing some problems. And I won't be able to do, as I said, all 100 problems that I have in that link. I leave it for you to do it on your own. It's not a homework. I'm not asking you to submit all, screenshots of 100 of those, but you should do them. What I will do though is give you 3 to 5 problems you haven't seen before and ask you to solve them based on numpy and torch operations. So definitely doing those 100 examples should help you to solve things, all right? And then we'll talk once we come back after Labor Day to see how you guys did on those problems. But they're very important, okay? They are easy, but by problem 30, they're not easy anymore. Okay? All right. So, but we'll start here. So let's create an array. How about that, right? So let's create an array in NumPy. So I'm just looking at my GitHub, right? So in the GitHub, right here, right? I'm going through these. I call it 100 plus essential linear algebra operations for deep learning, right? And I'm literally going over problem 1 to 15. I'm literally looking at this Jupyter. that I have on the GitHub, and I'm just gonna do this. And it's as simple as that for problem 1. But it's problem 1. All right, so let's go ahead and do that one. So let's start there. You know, how do we create you know, Python has a list. That's the native structure for it, a list. But we can't really use lists in Torch, so we have to convert things to tensors. You can start by converting something into numpy. You can directly convert it into Torch. You can take a list, convert it to numpy, and then convert it to Torch. It's up to you, right? You'll appreciate having that flexibility later. So in this example, I'll do the simplest thing, which is I'm going to create a list with integers. So I'm going to do 4, 5, 2, 6. Oops, sorry. These are comma separated. 6, 8. Okay, that's a list in Python. We have to convert it to a numpy array. So I'm going to do NP because I declared numpy as NP, right? So that's how I'm going to call it. So NP dot array. There are various ways of doing this. Okay, so this is just one of them like that. You guys see that? So it is no longer, after this, A is no longer a list, but it is going to be a numpy array. So then you can do A or print A. Do that. Okay. One of the first things we're going to try to do is look at shape. A dot shape 5. Seems obvious, but this operation, A dot shape, is one of the most important operations in deep learning. Why? It goes back to that X, the M and the N, right? So I was asking, is it 784? Is it 28? That is, you see those values here. So what I mean is, eventually you're going to have that X that we were doing in the word problems, and that Y, they're going to come into the code as X and Y. And then you'll do X dot shape, and it'll be 1 million by 784. And the Y, 1 million by 3 or 1. And you have to get into the habit of thinking like that. Okay, that's the key, the secret sauce, if you will, to understanding deep learning and playing with it. Okay? All right. So we did one example, and that's it. Problem 1 done. Very easy. Any questions? Okay. So as I said, go through all these problems, and from 1 through 107. I don't have, like, there may be a 34 and then it jumps to 37, but go through them as much as you can, at least for muscle memory. And then, as I said, I will create a homework assignment with 3 to 5 problems. They'll be like word problems. So an example of it might be create a matrix that is 10 by 20 and do this. Okay. Right. And then that homework, we'll see how you do. And then I might extend it a little bit, or I might add more problems later. All right, but we will start coding our first technique, linear regression, when we come back from Labor Day break. All right, so we will start coding some of this, but for now, I really want you to focus on these problems. All right, so, all right, we did problem 1. Now you would go back to this, and you can look at problem 2. Just like that, another simple one, and type it up. Don't just read them, I would recommend, because when I say muscle memory, I do mean muscle memory. Practice them out, right? It's like, try code it up, running it, become familiar as much as you can with this. And I promise you, once we get into later in the semester, this will help out a lot, okay? All right, so let's do problem number 2. As you can see, very similar, but I'm going to change the data type. So I'm going to copy it, actually. I'm going to do this. All right, so if you notice, I'm creating an array similar to the previous one, but the previous one was integer values, right? It says array. That tells you that it's a numpy array. This one, when I run it, it makes all the values float, right? So got it? Float values, basically. All right, let's do another one. So now let's go to problem 3. Okay, this is a matrix. So this is a matrix. So this would be equivalent to that X that we were talking about before. All right, so I'm going to go ahead and copy this one. And notice that I'm starting with just a list for now. So we're kind of like hard coding the values, but we're going to start changing that a little bit as we move forward. So here, calling it a list of lists because it's natively in Python, a list of lists, right? And notice that the list of lists goes into this function mp.array, and that's converting to a different data type, like a different data structure that we can use in NumPy. The advantage is if you had to process this like this, it would be very slow. Think of it that way. And when you process it like this, it's very fast. So if you're training a massive neural network, you want it to be fast. Okay. All right, so let's go ahead and do that. And you can see it is now an actual matrix. All right, so now I can think of, okay, I know this function shape. So I'm going to do b dot shape. 3 by 3. Do you see that, guys? Make sense? Very important. This starts getting into this idea of X. So it could have been 100 by 784, for instance. Any questions? Pretty easy, right? Very easy. Okay, good. All right, so now let's do another one. As I said, let's build up some of that background. So problem 4. Okay, now, instead of hard coding the values, you want to start doing things where you initialize with zeros, with ones, with random values, and so on, right? So for whatever reason, we're going to need to do those things. So problem 4. Can I add it in here? Okay, so this one is numpy zeros. So that means that all the values are going to be 0, but the dimension is 10. It's a vector of 10. The data type is integer. So one thing with these languages is that they're very verbose. And what that means is that you see things like this, where you say it's 10 and it's a data type is int and a whole bunch of, that's verbose. There's a lot of information there. Okay, so we run this one. As you can see, there's your numpy array. Okay, we can do b dot shape. And it's 10. Got it? Okay, so let's keep going. We're going to do, we did problem 4. Let's do problem 5. So this one's more fun. Okay, let's do. Going to add more cells here. Okay, so what is this one doing? So I'm using numpy. It's going to create all ones. The data type is going to be float, and now the dimensions are going to be 4 by 6. So this is a nice one because it'll help me to show you the thing with X and Y, right? So I have more dimensions now. So I'm going to run this one 4 by 6 here. Okay, I can also do b dot shape 4 by 6. This is really important. Especially your data is not going to be ever 4 by 6. It's going to be 1,000 by or 60,000 by, I don't know, some really large numbers. So it makes no sense to print the data. What will make sense is to look at these dimensions, okay? So you got to get into the habit of that. So now I'm going to do the following. I'm going to create, we're going to take the previous exercise that we were doing, right? Which is the word problem. So I'm going to call this X. And I'm going to take one of the problems. Let's do, what's one of the problems that we did? Which one? One of the word problems? The what? Well, let's do one of the ones we actually solved. Another one. Give me an easier one first.
Translation.
That's a hard one. We can do that one actually. But we said it was like 1,000,000, right? Let's not do 1,000,000 because I don't want to break my, this is cheap computers. Let's do, what's something that's good enough? Let's say like 1,000. So 1,000 samples. And then the text was 5,000, right? Yeah, 5,000. So, sorry, 5,000. That's literally the matrix that we are, and then it's X, right? And does it make sense to print X? No, that's what I was saying. So that's pretty big, right? So, but this is very useful, printing the shape. So now I run it. There it is. That is what this is how those word problems connect to the code. Do you see that? When you solve a problem and you do all that, spend a lot of time figuring that out, and then in the end, you need to create a matrix that can hold that data. Do you guys see that? Now, what about the Y? In this case, that Y that we were talking about was about the same size, right? So it would be pretty, basically the same thing, right? 1,000 by 5,000, yeah. And then just change this one to Y. There you go. So this is how you would load your data. And you would start then to build your network architecture. Okay, any questions? Now that, we can create the matrices here, and then currently this matrix just has all ones in there. Okay. Let's do one more of those X's just to kind of, and then we'll move on to another problem. So what was another one of the word problems we did? Which one? The what? Airbus, right, Airbus. Okay, so let me copy this one. And all we have to do is change the dimensions, right? So what was the Airbus one? How many samples did we say? 10,000, okay. One more 0 here. And then what was the number of features? 784, right? Because it was images. Should it be float or integer? Integer maybe, okay. So it could be int. And there's various data types. Okay, and it's X and 10,000 by 784. This is actually a very familiar set of shapes. Okay, and there you go. It's as easy as this. Now loading your data, it'll, you have to write some code. Maybe it'll come from a CSV, somewhere like that. In all these 109 problems, you're not reading any data at all. So the focus is on just doing the operations. So you always initialize your matrices and vectors like this, okay? Yeah. And then usually, instead of it being all ones, it's usually going to be random values. That's the only difference. But because really what I want you to understand is the operation and not get distracted, which what can be very, very difficult sometimes, of reading the CSV and processing. Okay? Got it? All right, so let's do another one. Another problem. But hopefully you guys are starting to see the main idea. I'm going to go to problem. Oh, I'm going to go to the GitHub. So we did 5 already, it seems. So let's do problem 6. 6, let's see this one. All right, another one. This allows you to create based on the number. You see, pretty straightforward. Hopefully, so this is a matrix of 3 by 3, and the value is going to be 42. There you go. Want to change this to, let's say, something not too big. Just a kind of 7 by 3, something like that. You can see that. You can play with your matrices, vectors, and so on. And, this is how you can start doing your problems. Any questions? All right, let's keep going. So that was problem 6. Let's look at problem 7. Okay, oh, this is a nice one. So we're going to create a range, a vector of values. So let's go ahead and take a look at it. And believe me, these things are very useful. You never know when you're going to need to create a vector like this for some reason or other. Okay, so or these are the building blocks for positional encoding or for, you know, or for other constructs that you need in your algorithm. So in this case, you're going to use numpy a range from 1 to 30, and it takes steps of 3. So it's going to create a range like that, and there you go. So it goes 1, 4, 7, 10, 13. So it's taking steps of 3. Okay, and that's, you know, a vector that you've created. Any questions? Right, straightforward. All right, problem 8. See how quickly we're moving through these? So you can definitely do all of these. All right, so problem 8. Line space, okay? Similar, but for decimal points, okay? Right, floats. So NP lin space goes from 0 to 1, and it's gonna be 20 value, okay? So there you go. Right, it's increments of like 0.05, right, roughly. Okay. All right, let's do another one. So yeah, that's the idea. All right, so problem 9. It's this one. All right, so this, random, I like this one. So random actually is something you will be using a lot because, as I said, you will not be reading data from any source for these examples. Later on, obviously, as we start, we need to read data, okay? But in these problems, you will usually just initialize everything randomly and concentrate in the operations. The solution makes no sense to look at something that's 10,000 by 5,000. So it's really about the shapes, getting those shapes correctly done, okay? And learning what a matrix multiplication is, for instance. You know, we're going to learn to matrix multiply things and how that works versus the element-wise multiplication. Sometimes you may need an element-wise multiplication. Sometimes you need a matrix multiplication, okay? So these are operations that we need to start to dissect and understand. All right, so in this case, I'm invoking numpy dot random random 4 by 4. Okay, you can look at it. I kept this one small so that you can see the values in there. What, you know, basically these values are random. Okay, random numbers. You can change this to like 6. And it just changed. Okay. All right, let's do the next one. So problem 10. So we're almost at 10% of the problems. 10 is here. All right, so this one is similar, but a mean and it's a mean and a standard deviation, basically. So a little bit more precision. A little, oops, sorry. Sorry about that. All right, so basically here we use NP random normal for a random normal distribution with a mean of 0 and a standard deviation of 1, and we specify the dimensions. Okay, why would you need this? Sometimes in deep learning, you initialize like the weights, right? But the weights, you don't always want to initialize them, you know, fully random. You want them to have a special distribution, etc. It might help in the learning process. All right, so that's some justification I can give you as to why these things exist. Okay, so let's just go ahead and run it, and you can see these are random. You can see there's pluses and negatives here, whereas before we didn't have that because the mean is 0 with a standard deviation of 1. Got it? Everyone with me? Okay. Again, you know, you can change the dimension. So this one, let's do 6 here. And you can see right there. Okay. All right. Let's keep going. And as I said, I think you get the idea. Just go through all of these as much as you can, even if you don't understand what it is, just still do it. All right. And then throughout the semester, I will definitely touch on a couple every week or something like that. Okay. All right. So we were in 1 to 15. So what was the last one I did? 10. All right. So let's do 11. All right. So this is the identity matrix. the transpose, although, you know, these are operations that you need to perform, you don't need to get into like the proof of why in linear algebra this is true. Okay, we're not going to do that. Take a math course for that. All right. So I'm just going to show you that sometimes you will, though, need these operations. Okay. So you will need it. And you'll see when I'll bring up the situations when you will need them. All right, guys. So let's do one here. So this is problem 10. It's called, this has a name. It's called the identity matrix. Sometimes you may need to do this. And here I'm just showing you how to create the matrix. So you can see that here. And see, the important thing is the diagonal has all ones and then all zeros. Okay. I can try other ones, other size, like 10. And you can see that. Got it? This might be a matrix that sometimes we need to use. Okay. Got it? Everyone with me? All right. So again, I'm just showing you some of the operations. Practice them a lot. Okay. Let's do another one. So here, I'm going to show you something called a transpose operation. Okay. Sometimes we need to do this also. So here I've created I have a list of lists, right? And I'm going to invoke numpy, and I'm going to generate a matrix like this. The transpose, just think of it as an operation that will take it and kind of just do this to it, okay? Like that. Sometimes your data may, and this is a classic problem that you're going to encounter. You read your data, you're trying to figure things out, and you read it like this. And you want to perform an operation like a multiplication, and it just doesn't work like you have it. But if you transpose it, then it's going to work. Do you see what I'm saying? So this is something that we will do in our code, and it's something that happens in transformers, etc. Okay, and it all comes from the fact that it's all based on linear algebra, right? So those are the fundamental operations that we're using. Okay, all right. So here, all right, I created this one. Now I'm going to invoke the transpose function. All right, notice that I did n here, right? So n is this n that looks 1, 2, 3, 4, 5, 6 like that. So that one is a 2 by, oh, I'm going to do this. So I'm going to print the shape of it. N dot shape, right? And that is a 2 by 3. This is really important, okay? Because you won't always be looking at the data, but you will see, it's 2 by 3. And then you got to do like, oh, wait, this needs to be 3 by 2. Do you see what I'm saying? So that's the hard part sometimes, okay? That might trip you up in deep learning. So now I'm going to go ahead and do the same thing. So NP transpose becomes P transpose. Run it. You can see it is now moved it like that. And you can print the shape as well. And it's going to be P underscore TRA dot shape. And now it is 3 by 2. Make sense? Notice that you have to also keep in mind how it moved it, right? So the first row becomes the first column. The second row becomes the second column for this operation. Make sense? Yeah. All right, great. So again, practice these things. We need certain functions like this to operate. So let's look at another one. Problem 12, I guess. Okay. All right, so now this one is just a little bit more, showing you some of the capabilities that we have. As you can see, now I'm introducing several matrices. This is building up to performing, what if I have 2? How do I add them, multiply them, and all that, okay? And then I'll get into some ideas here of how this ties to neural networks probably in the future. Okay, so I'm gonna copy this one. All right, so what am I doing here, right? So I'm creating B1, B2, B3. Okay. So it's rand int. So I'm going to run this. Okay, so they're all within 20, right? Guys, so random numbers within 20 ints. The first one is of size 6, which is B1. I guess I didn't print B1 at all. B1. Six, there you go. B2 is of size 3 by 4. So here I'm printing ndim. Okay, the number of like the rank of it. Then yeah, this one B3 is a little bit more complex. But this one is 3 by 4. So it should be this one, right? 3 by 4. So it's 3 rows and 4 columns. Now notice B3. B3, I'm saying that it should be a 2 by 4 by 6. That's not a matrix. What is that? It's a cube, right? It's a cube in every sense. So that's the other little bit of a difficulty with deep learning and this kind of thing, that tensors are not just vectors or two-dimensional arrays, but they can be 3-dimensional, 4-dimensional, 5-dimensional, and you just have to develop that intuition, okay, of what you're looking at. So think of it as a cube and a hypercube and so on, right? Why does this happen? Because sometimes we're going to have color images, and then we're going to have several of these images, and they'll have dimensions. So let's think about that a little bit. So I'm going to do an example here. I'm going to call it B5. And I'm going to say that this is 64 by 3 by 220 by 220. And then I'm going to print B5 dot shape. Do you see that? This is a hypercube. It's not, how many dimensions does it have? It has 4 dimensions. You've never even, we can only visualize a cube, right? We can't visualize a 4-dimensional cube, but that's what this is. Okay? And that's why these things are called tensors. That's where the name comes. We use that one word for all of these. So in this case, why do we need to create, why do we need to create a tensor of such size, right? Well, the first 64 will imply that we have 60, in this case, in this scenario that I'm using, the first 64, it basically signifies that I have 64 images. Think of it that way, right? And every one of those images is color. So there's 3 separate grids, RGB, yeah, RGB. And then the 220 by 220 is the actual image dimension. So for 1 dimension is 220 by 220, but then, so that's a 2-dimensional matrix already, but then we would have color, so we need 3, and then we would have a batch of 64 images altogether. Does that make sense? So that's a good example of how to think about these tensors. Don't worry if that seems a little bit complicated right now. The point is to get used to these operations, okay? And then it'll start to make sense. But this could be your X, actually. Do you see that? So we could have a word problem like this, right? Because this could be the Airbus thing. Remember we did that Airbus 320? Okay. What did we say about it? What was the size of the images that we said? 28 by 28, right? Okay. Well, here it is. So 28 by 28, but it's color. If it was black and white, we have to for a torch to work, we will have to create tensors of shapes such as this. Torch is actually very particular. It will want the format to be like that. The batch size always goes first, then the color, RGB, and then the size of the grid itself. So in this case, 64 by 1 by 28 by 28, or 64 by 3 by 28 by 28, okay? If our image, when we read in our image, it's 64 by 28 by 28 by 3, we're going to have to reshape that tensor to be 64 by 3 by 28 by 28. That's just, you have to learn those techniques. But that's the point of these problems, is that one of them will probably show you how to permute and move the dimensions around. Got it? Again, this is what we will be doing all semester, but I like to show you some of the building blocks in the beginning so that, you know, you don't get 6 of these in one algorithm at the same time. All right, you should see them initially separately. All right, so it's 7:41. Okay, so I think we are almost at the end of class today. How many problems did I do? I did 12 problems. Hopefully I showed you the basic idea, run through them kind of mechanically, right? Build that muscle memory, practice them several times. They're not homework. I will give you a few problems that will use some of these techniques, 3 to 4 as homework. That'll be due 2 weeks from today. And then, like I said, some of the advanced concepts and these things like broadcasting, etc., I will discuss throughout the semester. Any questions about that homework assignment? So it'll be word problems, and you'll have to solve them using these techniques. Okay, I'll try to make it appropriate to what these are. Questions? All right, guys, so we can stop here for today. I'll repeat again, just so far right now, try to go through all of these, you know, run them, get familiar with them, and then we will come back to them throughout the semester, and I'll give you a homework assignment. All right, I'll stop the recording right now. I'll stay for a few minutes if you guys have any questions.